Alright, so welcome back to our Python class on machine learning basics, and we are trying to classify some flowers. This is a classification task. We have some answers, we have some labels, we have some features with some labels, and we want to build a model on this. So now we loaded the data and we saw that there's some values missing. And again, in this notebook we're talking about how important the visualization is, right? It's hard to say is anything okay. Okay, we know some values are missing, but otherwise it's okay, right? Well, it's hard to say. So we will want to do some plots. We'll usually, again, these are quick plots just to show things. We'll want to use seaborn. Again, seaborn is using matplotlib, making a nicer looking matplotlib. If you don't have it, but I'm pretty sure you have it. Let's check. Remember how we could check, right? We can do this show seaborn, right? Seaborn, right? Seaborn, right? So I'll do pip show. I think this will work. Pip show seaborn. Pip show seaborn. It should work. Yeah. It tells you what it requires. Matplotlib, NumPy, Pandas, actually, right? Author, somewhere there. Let me see the license. If you can see this, right? Statistical data visualization author, right? You can see his Gmail, right? So pretty nice, this pip show, right? So you can check if you have it. I have version 0.12, right? Maybe you have a newer version, right? Again, so you should probably have the same one. So we are good. So we don't have to install it, right? This would work. This would install. This would install. Right, seaborn. Right. So I'll use here. This would install if you don't have it installed, right? So this is of course directly, but okay, we have it, right? This also, some of these instructions are not required anymore, right? So install pyplot as plot, right? And we used this before, and seaborn as SB, right? This is actually was not required. I think inline. I think it is inline. Inline is the default. So already. But just in case, just to be explicit, right? So let's run it. Again, one of the most common plots we want to use is scatter plot matrix, right? So we can plot the distribution, every column versus other column. So two different columns versus each other. So these will provide you some idea of how data is distributed. Also, they're nice because they also give you a histogram or a value distribution, for the values. So, what columns do we have? Let's check. We have sepal length, right? So these, okay. So we don't want to, well, class, right? So class will be for coloring. Let's get our info. We already did this before, right? We have it already, and let's plot it. So pair plot. Hue will be class, so we will use a column to use for color. Rest is numeric, right? So let's do it. Let's see how it works. Pair plot, right? And right. So we have kernel density graphs. So what are these things? Kernel density graphs, estimators. So in case if it's sepal length versus sepal length, so petal width versus petal width, right? So each column versus itself, there's no point of plotting it, right? So you do not histogram, you do a density estimation graph, so you can see how the data is distributed. But now you should see we can do it big screen. Can we do big screen? We can copy to clipboard, of course. We can expand image, right? Oh, how nice, big, right? We can expand, right? We can see it here, right? Some extra stuff, right? I'll go back, right? I don't know if actually, I don't know if now I won't be able, plots here. Okay, it's plot separate picture, but yeah. So you can save to disk, of course, right? For more analysis, but there's some problems should be immediately apparent, right? First of all, couple things, right? There's some data. Look what's happening here. There's some weird data around 0, I think, right? Yeah, it's around 0, right? You can see how symmetrically, right? These are, symmetrical, right? So some other things, of course, you like to see some bell curves, right? So that's a good idea, good sign, right? But also we see another problem. You see, for some reason you have five classes, but if you remember our original data set, you are supposed to only have 3 classes of flowers. Of course, taking a quick look, you can see these are obvious mistakes in labeling. Again, something which happens every day, right? Some typos, some maybe somebody decided to use different way of writing, right? So we'll need to fix these, right? These will be some data cleaning tasks we'll need to perform, right? So we already have a pretty good idea on what to do next, right? So some problem areas. So we can drop also the drop NA graphs, right? So actually this used to be, again, used to be required, now it's been fixed. This used to be a couple of years ago, you had to do this, right? Drop the NA, right? Drop the missing values for the duration of the code, otherwise it'll look exactly the same right now, so it won't be anything specific, right? So we saw the 5 classes, that's a problem, some outliers, and we had to drop some values. So we'll start with tidying the data. The step 3, right, is of course the garbage in, garbage out principle. We have some errors, we need to fix them. So 5 classes, there should be only 3. So how to fix them? We'll use, again, like I said, some forgot to put iris, some put iris setosa, this is a typo. So we'll use basically some Pandas operations, right? So class, you have unique 5, right? We can see some, notice this describes statistics for object, string columns, right? So include all, right? So we see that. So unique, very useful command, remember? Unique, we have of course 5 of them, right? So that's, again, these seem like obvious things, right? But again, if you have 150 or let's say 3000 features, right? I mean, labels, different labels, of course, you're not going to be able to count them yourself. Okay, so we're going to do just replace. So location of versicolor, right? You can see them here, right? Location is equals versicolor, and you can get the class. So this will show you, right? Will show the number of unique, well, show the rows where class is versicolor, right? So yeah, 95. Okay, so you see, of course, and also I got class, right? Where class is versicolor, right? So right, which we already did, right? So this will show you all columns. So this just shows single column, right? Rows with class column, right, where class is, okay. So but here of course I could do, remember, if I don't include class, right, I can do class is versicolor. These are the 5 we had to fix, right? So it's easy. We say, okay, iris data location, iris data class equals versicolor. We take class value, we rename it to iris versicolor, right? Now let's check. So this should be our first step. So 1, 2, 3, 4. So we already are doing good. Do we have time to do one more? Yes, we do. And let's check, same idea. Let's check for iris setosa, right? Again, iris setosa here, right? And now let's change it to wherever is iris setosa class, you'll change to iris setosa. Again, there are other ways of renaming, but these are, again, this way of renaming, we have a record. Again, we have a record what we are doing. Again, if you just somehow saved it, and cleaned it and didn't leave the record, it'd be really hard to replicate this, right? So now it's looking good. Looking good. Iris data tail, right? Looking good. And looking fine, right? All the data is in. Unique, main thing is unique. So we have fixed 1, 2, 3. So let's save it if you have time to save it. But we'll do it maybe in a little bit. We'll save it in a moment. Or intermediate step before we finish. All right, let's do this. Fixed, we can call it now before we step, right? We can file it as a iris data, save the data, iris data to CSV, data clean. We don't use index clean. I'll call it no three types, right? 3 labels, right? Something like that. And we are done for now. Our first step of cleaning is done.